So we have worked limits and gotten an infinity as our answer. But we've never had a limit where x is approaching infinity. So if, as our function goes to positive infinity, sometimes it equals a specific number. So that is called a limit at infinity. Okay? It looks something like this. As I'm going forever, as my x is getting larger and larger and larger, my graph is leveling out. What would you call this line? Y equals L. That's a horizontal asymptote. So when we have those horizontal asymptotes, as our graph is going off to infinity, it's giving us a single number. And we can do the same thing with negative infinity. So as I'm going forever in the left, it could approach a single number. Now, we have talked about horizontal asymptotes in college algebra, but we never had a problem that had two horizontal asymptotes because we were always looking at rational functions and they always had a single asymptote that you approached from both directions. But it is possible to have different ones, so that's why we have to consider both the left and the right. If either of those, as you go to positive infinity or negative infinity, if either one is equal to one specific number, then that's a horizontal asymptote. It's possible they could equal two different numbers, in which case we have two horizontal asymptotes. Just a scenario where that happens is, if you think about arctangent, so tangent inverse. When we graphed it, basically took our tangent graph and flipped it on its side, and you can see we have one horizontal asymptote as we're going to positive infinity, and we have a different one as we go to negative infinity. So when we are looking at equations and finding horizontal asymptotes, we can't just say the limit as we go to infinity. We'll also have to do the limit as we go to negative infinity. A lot of times those will equal the same number, but it's possible that they could be different, so we have to check both. We can't make the assumption that they will be the same. So we're going to start just by looking at a graph and answering some questions. So I want all of the infinite limits. Infinite limits, we saw those on continuity. We talked about the infinite discontinuity. Infinite limits are saying when the limit is equal to infinity. So those happen at like your vertical asymptotes. So can you tell me, looking at this graph, anywhere where the limit as x approached some number would equal positive or negative infinity? So at -1, we have a vertical asymptote. Limit as x, f of x, or limit as x approaches -1 of our function is positive infinity. Are there others? Okay, so we would have to look at 2 from 2 different directions. As I approach 2 from the left, so as I'm coming in from the left, that goes to negative infinity. As I approach 2 from the right, it is positive infinity. So these are what are called infinite limits, when our answer is equal to either positive or negative infinity. And those identify my vertical asymptotes. So then we can say, equation of a vertical asymptote is what? Vertical lines, their equation would always be x equals something. So it's just these x values. So we have vertical asymptotes, x equals -1 and +2. And we could draw those in if we wanted. We can see those are the places where our graph is approaching, but never actually hits those values. All right, limits at infinity are when x is going to either positive infinity or negative infinity. As my graph goes forever in the positive direction, do we have a limit? Yeah, what is it? As our graph goes forever in the negative direction, what is it approaching? My x is getting smaller and smaller and smaller. This is leveling out at 2. These are called the limits at infinity. And they give me the horizontal asymptotes. So this graph actually had 2 different horizontal asymptotes. We had one horizontal is y equals at y equals 4. And we have one at y equals 2. Are there questions on those problems? How I got the limits or the asymptotes? Let's add some equations. If I want to find the limit as x goes to infinity of 1 over x, different ways to get it. We could think about the graph, or we could plug in numbers. 1 over x, that's a reciprocal function. That's one that we had back in college algebra when we did transformations. What's a reciprocal function look like? Or if you don't remember, how can you graph them? Okay, if I put in a 1, 1 over 1 is 1. If I put in a 2, 1 over 2 is 1/2. If I put in 1/2, 1 over 1/2 is 2. Can't put in 0. If I put in -1, we get -1, -2, -1/2, -1/2, -2. So it looks like this. And if you graph it on your calculator, you would see the same thing. It's not the best today, but. All right, so can you tell me the limit as our graph goes to positive infinity? Yeah. I look at this graph. As my x is going to infinity, that means my x is getting larger and larger and larger. What y value is this approaching? 0. As my graph goes to negative infinity, so x is getting smaller and smaller and smaller, what's this going to? 0. Grab a calculator real quick. All right, so if we wanted to think through this, we could just plug in numbers too, right? That's another option. As x is going to infinity, it's getting larger and larger. So you might put in like 10, 100, 1,000. What is 1 over 10? What is 1 over 100? 1 over 1,000. Okay, so we can tell this is going to positive infinity, and this is getting smaller and smaller. It's going to 0. Right? If you did the same thing with the negatives, we're going to negative infinity. So looking at the y's, 1 over negative 10. Negative, or 1 over negative 100. 1 over negative 1,000. And so we can see this is, again, going to 0. We are going to be getting into this section, kind of reasoning through some of these limits. So you can look at a graph, you can plug in numbers, but we can also think about it. So if I buy one pizza for this class. Okay, right now you each get a small slice of pizza, right? But then if I invite Mrs. Dyer's class to also come in here and we're still splitting our one pizza, what happens to the amount of pizza you get? It's getting smaller. If I invite Mrs. Keller's class to join us, it's getting even smaller. If I then bring in the gym, then it's getting smaller. So if I take my one pizza, as I add in more and more and more people, the amount you get is getting smaller and smaller and smaller. So it's going to 0. Does that make sense? Okay. So we are going to use this property a lot. Anytime you have 1 divided by some power of infinity. So it could be like x squared, x cubed, x to the 4th, it doesn't matter. If the top is set at a single number and the bottom is getting bigger and bigger and bigger, then that's always going to be going to 0. Okay. When I throw in a square or something, it's just getting to 0 faster because I'm bringing in people even faster than before. So this property is going to be really useful for us if I'm trying to solve some kind of limit like this. If I just tried to plug in infinity, that's not really very helpful at all. I would get 3 times infinity squared minus infinity minus 2, 5 times infinity squared plus 4 times infinity plus 1. Does that even make any sense? No. So we can't reason through this at all. But let's try to see if we can figure out what it would go to. So we know we can use algebra tricks, right? We can try to cancel things, but there is a really simple trick that's very effective here. In a fraction, it is legal to multiply both the top and bottom by the same thing, correct? So what I'm going to do, what is my highest power of x in this problem? X squared. So what I'm going to do is multiply by 1 over x squared. And since I can't change my problem, I have to do it on the top and the bottom. So on the top, 3x squared times 1 over x squared would give me 3. Minus x over x squared would reduce to 1 over x. Minus 2 over x squared. I can't reduce that. On the bottom, 5x squared divided by x squared is 5. Plus 4x divided by x squared would be 4 over x. Plus a 1 over x squared. Okay, at this point it doesn't necessarily look like I've helped myself a whole lot, but I have. Because regardless of what we're approaching, if you have the limit of a constant, it is equal to that constant. So I have 3 minus. What would 1 over infinity go to? 0. Okay, minus 2 over infinity squared. Okay, if I buy 2 pizzas and I start inviting more and more and more and more people in here, what's happening to the amount of pizza you get? It's still getting smaller and smaller. So it doesn't really matter what the top number is. I have a set number of pizzas to start with, but as I invite in the whole school, the amount of pizza you get is going to 0. Okay, the bottom. 5 will just be 5. Plus, what would 4 over infinity go to? 0. Plus, what would 1 over infinity squared go to? And we get 3 over 5. So it turns out if you have a number divided by infinity, doesn't matter what the number is, it doesn't matter what the power of infinity is. Anytime you have a number over infinity, it's going to go to 0. And we can use that trick. And this actually kind of goes back. This is the horizontal asymptote here. Do you remember in college algebra when we graphed rational functions and we had all these asymptote rules? And I said, okay, if the degree of the top is smaller, your asymptote is always 0. If the degree of the top and bottom is the same, you divide the leading coefficients. That's why. is because of this limit property. So in college algebra, we just memorized rules as to what it was, but now we're seeing from the calculus why that rule actually worked. All right. Let me try another one. Right, I want horizontal and vertical asymptotes here. Let's start with vertical asymptotes. I know those are just the places where we have those infinite discontinuities, right? And we know that happens where? When the denominator is 0. So to find my vertical asymptote, I just need to know when does this denominator equal 0. So I get x equals 5/3. The horizontal asymptote. To find that, we have to do two things. The limit as we approach positive infinity, and the limit as we approach negative infinity. 9 times out of 10, these are going to give us the same number, but we know, like for arctangent, for instance, we could get different answers, so we need to check both. So let's do the limit as we approach infinity of this equation. All right, if I just try to plug in infinities now, I have the square root of 2 times infinity squared plus 1 over 3 times infinity minus 5. Do we have any hopes of making sense of that? No. So we have to pick out our highest power of x. Now let's think about this. On the top, we have an x squared, but it's under a square root. So that's the same thing as an x. The bottom is an x. So my highest power is just x. So what we're going to do is multiply by 1 over x on top and bottom. Now, on the top, if I really want things to cancel, that x needs to be under a radical, right? X is the same thing as the square root of x squared. So what I'm really going to do on the top is multiply by 1 over the square root of x squared. It's the same thing as x, but now I can bring it under my radical. Does everybody understand why I'm doing that? So then when I bring that under my radical, I get 2x squared over x squared, which is 2, plus 1 over x squared. On the bottom, 3x divided by x is 3 minus 5 over x. All right. So if I plug in infinity, so I have 2 plus 1 over infinity squared over 3 minus 5 over infinity. So we get square root of 2 over 3. Are we okay with that one? So I know right now I have one horizontal asymptote. Y equals the square root of 2 over 3. I need to check the other way and see if I get the same thing or something different. Okay, so I need to start out the same way. Multiply by the highest power of x. So that's my 1 over x. On the top, we still have a square root, so we have to do square root of 1 over x squared. Okay, but I want you to think about something for a minute. The square root, I don't know. about this problem. The square root is messing things up a little bit. We are approaching negative infinity, right? So x is a negative number. So if x were negative 5, on the bottom I just multiplied by negative 1/5. But on the top, negative 5 squared is 25. Square root of 25 is 5. So what happened is I multiplied by a 1/5 on the top, but on the bottom I multiplied by a negative 1/5. Is that the same thing? So how do I fix it? Those have to match, so I just need to put a negative on this one. Okay, it's all because of the square root. The answer that comes out of that square root is positive. But because I am approaching negative infinity, I know I'm multiplying by a negative number. So then if we do this, I'm just going to leave that negative on the outside. So 2x squared divided by x squared would be 2. It's 1 over x squared. On the bottom we get 3 minus 5 over x. So if I plug in negative infinity, I have a 2 plus 1 over negative infinity squared. That's still one pizza divided by a really big number of people, so how much are we getting? 0. Come on, 3 minus 5 over negative infinity squared, or 5 over negative infinity would go to 0. So this time I get a negative radical 2 over 3. So it turns out this one has two different horizontal asymptotes. Y equals radical 2 over 3 and y equals negative radical 2 over 3. And that's why we have to check both the positive and negative infinite. Questions here? Let's do one last problem for today. So if I asked you to find this limit, I would have, if I just plugged in the square root of infinity squared plus 1 minus infinity, a really big number minus a really big number, do I necessarily know what that's going to? No. All we know right now is that if we can get a number over infinity, it will turn into 0. So what's the strategy we've used on a lot of our limit problems that had radicals? Well, we couldn't just add a square. What did we do? We always multiplied by something. Conjugate. Yep. So before we can do like the 1 over x on top and bottom, we need to do the conjugate here. So if you have radicals and you don't know what else to do, try the conjugate. So that would be the square root of x squared plus 1 plus x over square root of x squared plus 1 plus x. Right, so if I FOIL, the square root of x squared plus 1 times the square root of x squared plus 1. Cancel the radical. Because they're conjugates, outsides and insides drop. Negative x times x is x squared. What happens now? I can drop the x squared. Okay. So at this point, I have 1 over square root of infinity squared plus 1 plus infinity. Okay, if you take a really big number and add another really big number, what are you getting? An even bigger number. So 1 divided by a bigger and bigger and bigger number is going to go to 0. So the reason I'm able to figure it out now, and I couldn't before, is that before they were subtracting. And I don't really know which of those is bigger or how much bigger. But Down here, I was adding. And if you take two really big numbers and add them together, you know you're still getting a bigger number. So that's why we were able to figure it out at this point.
Why did we make that into a fraction? Like multiplying by the aggregate, how did we make it?
We had to do something because we couldn't figure it out right now. So we said, well, with radicals, the only strategy we really have is conjugate. So we just put this one over 1 to make it into a fraction, and then multiply that, in hopes that we could get it to the one thing we know, a number over infinity goes to 0. All right. So we still have a lot more to do with this, a lot more practice to come, but I am going to stop today. You could start part of this homework. 3 and 4 are both just looking at a graph and answering questions. 5 and 7 is drawing a graph to meet certain requirements. 13, it says to tell the properties. You do not have to do that, you just have to solve it. So technically, you could very easily do up 3 problem 7.